Welcome to another GCBASIC demonstration. This is part 15 for the 16F chip family, or legacy chips as I'm calling them. This is also applies to 10Fs and 12Fs. Generalize the tutorials and they should work for you. So this is part 15, the external interrupt, worthy of a special deep dive. Please like and subscribe to this video. Your likes, your subscription enables these videos and tutorials to be found on YouTube. Unless you do that, they don't get found. And let it run all the way through. So, external interrupts, part 15. We're at the back end of these videos. I've assumed that you've got GC Code and GC Studio installed. You've got your programmer installed. You've got your PIC, and it can be programmed. LEDs, a pot, some switches, a USB TTL serial converter, and you have an LCD. Why have you got all those? Because I've got them. The board I'm using is this board. It's a PIC15 Plus demonstration board, very sophisticated. I think we are just going to be using number 9, the LEDs. And normally now I switch out to the desk cam. But if let's have a look at the desk. You can see why normally look, this is the board. This is my oscilloscope that I was using. This is another camera looking at the LEDs over here. This is a light that I can turn down so you can see the LEDs. It's a complex setup to do the demonstrations, but I've got my oscilloscope that I can see on the screen here if I needed to. So I can see lots of different things. So look, that's another picture of the board. It's in very good condition. They are very, very inexpensive, and we've gone through a lot of the capabilities. But what we're going to do is push one of these switches on the right-hand side, and we're going to make an LED turn on, called an interrupt. So the layout of that board is as per. There is nothing different about it. We have got a switch on port A. I'll just highlight that for you. Port A4, we have a switch. There's another switch on there somewhere else, but I actually don't have it on the diagram because I've not used it. And we're going to pick an LED here to do our magic. So whenever I push that switch, an LED is going to come on. So let's look at some principles of interrupts, right? Principles of an interrupt is that an event happens and it will alter the execution of a normal program so that you can respond to a particular internal or external event. I used to explain this as you're in your home, you're doing your thing in the house, and the front doorbell rings. You go and answer the front doorbell. You have a look at them. You close it. The person goes away, shut the door, and you go back to where you were. And everything is restored back to where it was. So an interrupt is like someone coming to your home and ringing the front doorbell. You always go back to where you were, normally, in quotes. Advantage are it's immediate and it efficiently uses the resources of the microcontroller. But there are many different types of interrupts, not like your front door. There's external interrupts, and we're going to look at an external one, being a signal coming into the microcontroller. There's timers, there's peripherals. We've used the USART and the ADC. As they change state, they can raise an interrupt. And software can also do the same. You can make a software interrupt. There are some key registers. INTCON, PIEs, and PIRs, and they all have to be set up. But we're going to make it a little bit easier in GCBASIC. But typically you have an interrupt service routine or ISR. GCBASIC, you can call it what you like. It's a special function that gets executed when the interrupt occurs. Make it as short as possible and as efficient as possible. Don't delay things. Imagine that you're cooking something and it's on the boil in your kitchen and the front doorbell runs. rings, you go and answer the front doorbell as fast as possible to get back to the cooking. You don't want it to burn. So, doing long divisions, sending out massive serial information is the wrong place for your interrupt service routine. Do it in the main body of the program. The interrupts on this particular chip on a 16F1937 is a list of 24. I've got this list from PIC info. They start with ADCs. Have I got a pen? Yeah, they start with the ADCs through the CCPs, which is the the capture ones, capturing data. You've got some compares, EEPROM events, LCD ready. Oh, well, that's right. This particular chip has a set of drivers for an LCD. Did you know that? They raise very specific signals for the LCD. Very complicated, but never mind. The one we're going to be using is, well, we could just hide with these, like port change or port B change, like, because they're the same registers, like register bits. And there's many others, timer overflows and US aren't. Look at that list of 24 and compare that to this. This is a 18F new chip. 18F, doesn't matter which one it is, it's a Q24, 65 different interrupts. You don't have to be the world's expert because they're all supported in GCBASIC, but it's the same principle that says for every interrupt, it has a name. It has a name, something like port B change, and there's always two parts that will be automatically set for you, which is IOC, which is interrupt on change, interrupt enable. And then there's a flag one, which is what is the flag register? What is the flag register? So when that occurs, it will set that flag. So to enable it, you would GCBASIC automatically sets this for you. It will automatically pass it to your handler if that flag is set. You do your stuff in your routine, and then it will automatically clear that down for you. It's very simple. With respect to what we're going to do, interrupt on change, IOC, the microcontroller can detect changes in the state of a selected pin or selected pin or pins. You have to set up the pin as an input and configure the correct register in terms of whether you want to capture the rising edge or the falling edge. You need to define an ISR and you need to set the global interrupt. But do you have to do all that in GCBASIC? No. You must set the pin up in terms of its configuration. You've got to write an ISR, but the global interrupts is all managed for you. So how do I know whether I've selected the right pin? Let's have a look. Well, I can see from the diagram I've got here that I am going to be using RB0 as my input, and therefore my documentation was wrong. I'll come back to that in a bit. RB0. If I look along here and I look down the interrupt, it says that this supports interrupts and IOC. So do others, but that's the one on this board. RA4, which is the other switch, which I thought we were going to be using, doesn't support IOC. So I must be using port RB0. We'll look at that in the program. Here's a cut of what we're going to go through. So what it's going to do, the interrupt is going to be enabled because that's automatic. And we're going to say we want to have it on an edge. And that edge is going to be a positive edge because I've set that to 1. Negative edge is set to 0. It says negative here, but I might flip those over in the program. We'll see. And this is the flag. I have to set a flag. And a lot of this, unfortunately, you have to find in the data sheet. Hence, we don't know this stuff. Only you know that stuff. And then I have to set that interrupt to an input. To make it all work, you just say this in GCBASIC, on interrupt port B change, call my interrupt handler. So this is your name. This is the event we want to capture. And down here, it says, when it occurs, toggle LED 2 and clear this flag. And that's IOC B, that's the port we're on, flag 0. And if I was using a different port on port B, so if I was using .1, .2, .3, this number here would change. So with these numbers at the top, these values would change. And so this is the real basic stuff, really simple stuff. We just go, you set up the edges, set it as an input, set up the handler, write the handler. Oh, that was awful. Let's have a look at some code. Have I got GC code working? I have. There it is there. Control B or to open the Explorer. 250 or 250 using external interrupt to raise an event. Control B to get rid of that. Let's have a look what my documentation says. Oh, look. My documentation was wrong. Look, it says here there's an interrupt on port B. So my documentation is correct here, but not correct in the PowerPoint, which I shall correct in a moment. We have no GLCD attached. But look, we have an interrupt on port B. Great. Let's see what our program does. Well, it's exactly what I just showed you in PowerPoint. We're going to set up the edges here, set up the flag, put int 0 as a, oh, there you go, look, interrupt 0, look, as a constant. Set up the handler, interrupt on change port B, call handler, and then it flashes LED 2 and clears the interrupt flag. Remember, a lot of these flags are in the data sheet, but the logic here applies. IOC, port B, flag 0, flag 1, flag 2, flag 3, flag 4, 6 and 7, obviously. Function key F5. Let's see what's going to happen down here. It's just programming it. Well, you can just about work out that port B is flashing. Let me turn some more lights to get into total darkness here in the lab. Now that makes it worse. Did that make it better or worse? That LED is flashing. To me here, it's very clear. On the camera, it's tough. I'm going to push the button, RB0. So you can see that the LEDs are changing state, but I'm just going to put my pen on them so you can see exactly what's happening. One moment. This is the power button. This is RB3. This is the state of the push button. If I push the button, it goes off. And when I release it, that's the positive edge, RB2 will come on. It will toggle its state. So I push the button, and then when I release it, that goes to a positive edge. The LED turns off because I'm toggling it. On, off, on, off. You can set up extremely complicated and complex interrupt handlers. Essentially, I push, it goes low and high. Let's change that program to see what effect. If we said we wanted a negative, and we'll change that to a from the positive, I'll reprogram it. We're going to change the behavior because when it now goes negative, it will call the interrupt handler. Let me lean across. This is flashing in the main loop. I'm going to push the button, and when I push the button, you'll see your left-hand LED go low. And the moment I push it, this LED has changed state, and off we go. So what happens if we actually set those both to 1? So what we're expecting, you never know the results. I didn't do this in testing. It's going to flash RB3 permanently on and off. I'm going to push the button, and you'll see when I push the button, because remember RB0. Oh no, it looks like it's following me, but it's been toggled by an interrupt. The interrupt is making it look like it's on and off with the switch, but it's not. It's all been done through the interrupt routine. I think that explains it quite well. I'm going to put that program back as it should be. I will check the documentation in the PowerPoint and make sure that's all updated. So that's what I wanted to show you. View the scope. Why do I want to see the scope? What's the scope going to show us? Nothing. Doesn't matter. So what we're going to be looking at next is storage within the chip, program memory, EEPROM, and data blocks. If I show you the slides, it'll be even better. Program EEPROM and data blocks, and then we're done. We'll get at the back end of the presentation. So just 4 more to go. Enjoy.